Today I will present Narrative Weaver towards controllable long-range visual consistency with multi-modal conditioning. The goal of this work is to generate a coherent multi-shot visual narrative from a condition image and a user instruction. Instead of producing only a single image or a short isolated clip, we aim to create a sequence of keyframes that keeps the same subject, visual style, and environment consistent over time. As shown in the storyboard on the right, the model starts from a condition image and then generates multiple shots that follow a clear narrative progression. The key idea of our method can be summarized by 3 words: planning, control, and consistency. Why is this problem challenging? Existing image and video generation models are already very strong at generating high-quality single images or short clips. However, when we ask them to generate a longer visual story, several problems appear. First, there is visual drift. The identity, appearance, lighting, and background may change unpredictably across shots. Second, there is weak narrative planning. The model may generate visually plausible frames, but the sequence does not always form a coherent storyline with meaningful temporal progression. Third, there is limited multimodal control. In real applications, users often provide both an image and a complex instruction, and the output needs to follow both faithfully across multiple shots. The comparison on the right illustrates this difference. Existing generators may gradually change the character, identity, or environment, while the desired output should maintain stable identity, scene continuity, and narrative progression. So the core challenge is, how can we jointly plan the story and preserve visual consistency over long-shot sequences? To address this challenge, we propose Narrative Weaver, a unified framework that combines planning, memory, and attention. The framework has 3 main components. First, we use an MLLM-based planning module. It takes the condition image and the user instruction and generates shot-level narrative plans. This helps the model decide what should happen next in the story. Second, we introduce learnable query tokens. These queries bridge the language planning module and the visual generation module. They serve as compact visual anchors that carry high-level historical context into the diffusion generator. Third, we design a dynamic memory bank. The memory bank stores features from previously generated frames. During generation, these memory features are reused to preserve fine-grained visual consistency, such as identity, appearance, style, and environment. On the right, the attention mask controls how text tokens, image tokens, and query tokens interact. This allows learnable queries to access multimodal context without disrupting the original MLLM behavior. In short, the MLLM plans the story. The learnable queries connect planning and generation, and the memory bank preserves long-range consistency. Next, let me introduce the training strategy and dataset. We train Narrative Weaver progressively in 3 stages. In Stage 1, we focus on narrative planning. The MLLM is trained to generate coherent shot descriptions, while the vision encoder is frozen. In Stage 2, we train semantic visual alignment. The learnable queries and projector are optimized so that the planning representation can be aligned with visual generation. This stage uses large-scale, low-resolution pairs and then high-resolution samples. In Stage 3, we perform fine-grained visual alignment. The diffusion generator is trained with the condition image and the memory bank so that it can preserve detailed visual information across multiple shots. We also introduce EAVSD, an e-commerce advertising video storyboard dataset. It contains more than 330K high-quality images. Each sample includes a product image, description, marketing goal, narrative plan, and multi-scene storyboard. This dataset is important because it directly matches the real task: controllable image-to-storyboard generation for e-commerce advertising. Now we evaluate the first question. Can Narrative Weaver generate visually consistent multi-shot sequences? The qualitative comparison shows 4 methods. The baseline methods can generate reasonable images, but they often suffer from changed lighting, identity drift, or environment shifts. In contrast, Narrative Weaver maintains a more stable subject identity and environment while still allowing the story to progress naturally. The quantitative results also support this observation. In GPT-4o evaluation, our model achieves strong performance across multiple criteria, including identity temporal consistency, range gap consistency, multi-shot structural consistency, multi-shot color consistency, and image quality. The user study also shows a clear preference for Narrative Weaver, with 45.3% preference. Overall, Narrative Weaver balances long-range consistency with dynamic storytelling. We further evaluate whether the model can perform autonomous narrative planning and support real-world applications. In the left section, we show several cinematic planning patterns, such as cut-in, cross-cut, temporal cut, and reverse cut. These examples show that the model does not simply repeat the same view. Instead, it can automatically choose meaningful transitions, such as zooming into a key detail, switching to a related character, advancing time, or returning to a previous subject for continuity. In the right section, we show an e-commerce advertising storyboard. Given a product image and a marketing instruction, the model generates a 5-shot storyboard. The product remains visually consistent across different scenes, while the narrative gradually builds brand identity, scene composition, and marketing message. This demonstrates that the same framework can support both storytelling benchmarks and practical advertising workflows. To conclude, Narrative Weaver turns multi-modal inputs into coherent long-range visual narratives. The method has 3 key components. First, plan. An MLLM director generates shot-level narrative logic. Second, control. Learnable queries bridge language planning and diffusion generation. Third, consistency. A dynamic memory bank preserves fine-grained visual consistency across shots. Together, these components provide a unified step toward controllable AI-driven content creation, including video storyboards, advertisements, comics, and other long-form visual narratives. Thank you.